Super duper. Okay, so tonight, official start, sort of, kind of, slightly less miserably hot, all that fun. So tonight, what we're going to be going over is really just the basics introduction to what is CAD to begin with, and want to see where everybody kind of stands with all that. We're going to talk a little bit on just like the actual steps, how you go through modeling. Because one of the things about this course is this is designed to be a base level course, but you could always expand. So the intention of this course is, like I said, it is not a mastery course, but you will come away with a functioning knowledge of how to operate a CAD program, modeling your own models. The complexity is going to be up to you. So if you have no understanding whatsoever, it sounds real neat, and I would like to know some stuff, cool. That is where we can start with. If you have some experience, maybe you have a lot of experience, there's no cap to any of these modeling any of these modeling assignments. You can expand on them and make them as complex as you like, and I will certainly help you expand with that, or expand more on that. But the goal of this is, if you don't have any experience, then we're going to build from basics and build from there. So after that, we're going to do some introductions on with the actual program, Fusion 360, and then we'll go over and we'll pretty much go through that by discussing the full first assignment. So let me change over to just kind of the basics here. And switch to my screen of, all right, how to start modeling in CAD. What is CAD? What really is? So who has experience with any kind of 3D modeling? Super good. So everybody else kind of sort of just 0 to I've seen some things. Okay, cool. Where's your experience? Where, or to what level, that sort of thing?
I went to a technical high school.
Okay, great.
So I used Inventor and Fusion 360.
Why are you in here? I'm just kidding. Excellent, great. So you have a good amount of experience with Fusion 360?
We use Inventor more.
Okay.
I use it for the project.
Okay, then, cool. So really more here to learn more about 3D printing and that sort. Cool. So we'll get there. Get a little more experience with Fusion 360. Cool. So everybody else is kind of just more of baseline. That's fine. So just to really set the bar for that, what is CAD? Computer aided design, and it's kind of interchangeable with computer aided drafting and design. Basically, think of like drawing, so hand drawing, observation, that sort, with much more technical details. So if you were drawing, like, say, a square, great, basic stuff's there. But if you are trying to design this for like something with engineering or component design, meaning it's supposed to function within a machine or something, well, that means, especially with this, you'd be able to assign dimensions. So, 3 millimeters by 5. I know that's not, because that's kind of sort of a square and that's way off, but you get the idea. Then through the computer, you could also add additional dimensions. So how big is it? Such and such. How deep is it? If it has additional features, does it have cut throughs? That sort of thing. All this gets designed in the computer so that you can orbit the whole thing three-dimensionally, virtually, and really get a complete sense of what the object is, so that then it could be translated to some sort of output system. What that means is it could be taken to a machine shop or a wood shop, depending on what the material is intended to be. Or in our case, it could be translated to a 3D printer through a slicer program, which that's the intermediate program that takes your 3D model, prepares it for 3D printing, and you take it to one of those, regardless of the type. So there's a few different types of CAD software, or at least the intention behind. 2D CAD, two-dimensional CAD. Think of this as like the base level of like SketchUp, stuff like this. So this is very, very much flat drawings. So if you're trying to see this object from multiple directions, since it's a 3D object, how would that be displayed flat two-dimensionally? Well, from one side, you would have it looking that way. From another, it'd be flat and you'd be looking straight on, but technically that's where that sweep is. And then usually up here, it would actually be a top view. So we'll just sheet and say this is over here. So again, you'd be looking at it from above, but then you'd be looking at the sweep as it goes down and over. And then usually there'd be a fourth, traditionally there'd be a fourth view that is a perspective drawing like this. These are all out of standard order, but you get the idea. Two-dimensional drawing, you're looking at it from a variety of flat two-dimensional drawings. There is technically 2.5 CAD, which is kind of sort of, it's kind of prismatic. You can kind of see from multiple directions. It's irrelevant. Hardly ever gets used. The other version, which is the much more commonplace, and what we're going to be using is 3D CAD. So you can represent the object from multiple views, but you could also represent it three-dimensionally and then take that object and rotate it around and virtually, actually like it's in your hand, and rotate it around, zoom in, zoom out, all that kind of thing. So that's really what that breaks down to. And really that's really kind of the basic. You're just looking at three-dimensional drawings. That's really what a 3D version means, but CAD, of course, means the computer-aided version of it. So virtually you can do all that versus making like a paper model or something and then flopping it around, that sort. So there's different types of 3D models, 3D CAD models. You can have wireframe models, which a wireframe means you can see all through it. It's like wire. Anything you've ever seen, like wire. Of course, we're in an art room, so there's a bunch of different like wire things around. You can see through it. You can see all sides of it. There's surface models, which you are only seeing the actual flat surface. And basically what that is you have, let's go back to the cube here. So right now, as a wireframe, I can see all through it, both internal, external, all through. Gets a little confusing. A solid model deals with the surfaces, which in this case, wires are referred to as the edges. So it's literally just the edges. The surface is the flat surface between. So you're referring to, and it will be represented as an opaque object. And surface modeling, you are actually looking at these flat areas filling in between the edges. That is a surface. Solid models, kind of the same thing, only now I can like cut through it and play with different like actual material aspects, densities. The solids in surface modeling are, for the most part, terminology wise, are going to be kind of interchangeable until we actually get to surface modeling, which is more like sculpting. But for the purposes of, especially today, we're pretty much making like solid models. So we're starting with like flat sketches, flat drawings, creating 3D surface or solid models from that. So some examples here, and again, this is all on Blackboard. You could read all this. Some examples of this, things like object-based modeling, where some objects are created using like altered provided objects. So you're given some predetermined forms, like think of it like Lego blocks. Actually, that's a really terrible example. You're given digital representations of like a cube, a sphere, a cylinder, and then you alter those. You cut chunks away, you scale it up, you stretch it, that sort of thing. That's an object-based model. Parametric modeling, which we're going to get into this semester, is essentially you are creating objects, you are designing them, you are assigning dimensions to them. But by coming back and altering the dimensions, you can resize that solid object and keep the same features. It just distorts and reshapes with the properties that you have restated. Meaning, like, maybe I made all of this slope and all of this kind of thing, but you know what? Later on, I decided, oh, actually, this thing needs to be, instead of 5 millimeters, it should have been 10 millimeters long. You'll still have this side profile information, but instead of it only being 5 millimeters, you can go back, redefine that. It'll stretch the whole object. Now it's 10 millimeters long, but it still has the same shape, meaning that you don't have to go back and start from scratch if you decide you want to change some of the dimensions. That's essentially parametric modeling in a very concise nutshell. So those are both solid modeling. Surface modeling, like I said, they're semi-interchangeable, but it's kind of one of those of a frog is a toad, but a toad's not a frog. Now I'm just going to fry everybody's brain out. Like I said, surface modeling is your trick. You're working instead of with the edges, with the defined lines, with the drawings, you are focusing more on the actual surfaces there. And think of it in terms of you are creating more of organic shapes rather than defined linear shapes that you could augment. It's essentially the difference between, excuse me, kind of sort of building with Legos and actually sculpting with clay. That's kind of the best analogy I can say with that. So essentially, parametric solid modeling, you'd probably be designing something that was actually like had a functional purpose, like a wheel or a tabletop or something. Surface modeling would be like you designing like a helmet or something much more organic, like you're actually making a rubber ducky. I don't know, whatever. Kind of the basic difference there. So the other thing is these techniques can also be combined. It's not like you have to start with one and end with one or the other. You can combine these into complex models. Complex models. So you could have, say, like this more organic shape or something with defined features in it to where like, okay, well, it has this fancy organic shape, but that needs to screw down to something else. Think of it in terms of me dropping a mouse. Thought I could pick this mouse up. Cord's a little tighter. Think of it like a computer mouse. You've got the flat bottom underneath that may or may not have like a wheel or a port for a laser sight, something like that. But the top is more curved and ergonomic and sculpted. That would be an example of a complex model if you were to make a mouse. The bottom has to interact with the flat surface. It has to have a cord or a battery port or something like that, whatever. Something that kind of has some defined features. It's going to have to fit like a AAA battery. So the door on it needs to be so and such large and that sort of thing. The top, however, is much more sculpted, and it's designed to fit with your hand rather than an architectural object like a battery, a cylinder, that sort. So you can combine those two and work from different ways, or literally combine them inside the program to have your complete model. Very, very over-explained discussion on you can make stuff with straight lines, you can make stuff with curved lines. You can do a little bit of both. That's really what that comes down to. All right. Super. How and where do I start? Well, obviously, you pick a program we're going to be using Fusion 360. Essentially, you've got some basic ways to approach. Like I said, you can start with a predefined object and manipulate that. So again, maybe I wanted to make a mouse. Well, I could start with maybe a sphere, and I could kind of stretch and squish and play with that, like that. I could start instead with a drawing. So I could draw like, where'd all my erasers go? I think I threw them because I'm getting mad at them. You can start with a basic outline. So sure, it kind of has that kind of shape. It's flat. And then you take that drawing and what's called extrude. So it'd be taking that two-dimensional drawing and actually adding dimension by pulling that shape up in space and then manipulating it. So that'd be a way. Or surface modeling, which would be starting with some sort of object and actually really manipulating it at a surface level. Like I said, you really have a lot more control with the actual shape. There's not going to be a wrong method for anything we model in this class. But one, obviously, there'll be an assignment-based thing, so I want you to go through the steps I tell you. But more of meaning that as you gain more experience, there's not necessarily going to be a right and wrong way to approach modeling an object. There will, however, be a better way to do it. More efficient way, a better path, a better workflow, a different set of steps. Some models might take the same, or some assignments might take a very similar approach. Some might actually shuffle some of those steps because depending on what the steps are, or adding new tools to the workflow, to the steps, sometimes one thing needs to happen before the other. So that's one of the other things you're going to learn about in here is it's not just learning the tools and what they do, but learning the order they can be used in, and then also different orders that they can be used in. So it all kind of gets a little confusing as this kind of ambiguous discussion. As we start discussing things, as we start with a baseline and work and continue to work, it'll all become much easier to understand and just easier to do. So basically, like I already went over this, but direct object modeling, parametric modeling, just to kind of expanding on those. Direct object modeling is, like I said, starting with a pre-made thing, alter it, combine it, step by step, that sort of thing. There's no reliable way to get back and forth with object modeling outside of like just backup, command or control Z and stepping back. Oop, I didn't want to do that. Back. All right, let me retrace my steps. Parametric modeling does have some additional benefits. Usually, parametric modeling, what we're going to be doing, has history referenced modeling, meaning that this is why I was saying you can kind of shuffle the steps. In Fusion 360, there's a step-by-step timeline of the tools that you have used to a degree. Certain methods don't allow for this. We'll get to that. But basically, you've got a line of steps at the bottom of your screen that you can go back in, retweak, adjust the dimensions, something like that. You can go back in, splice or delete steps. So meaning that's what I was saying is sometimes you can actually add steps in between if you need to shuffle them around, things like that. But like I said, it's based on numeric inputs and drawings. So you'd actually be like starting with some profiles, that sort, adding things. Or adding dimensions, I'm sorry. Numeric actual like number dimensions. Complex models can be altered at any point in the process, meaning you can step back in time on any of these and add, subtract, alter them. When you finish altering that thing, whatever that step was, when you exit out of the whatever tool you're using, the program will recalculate and bring all of the other steps that you have done back in line based on those alterations. Sometimes that can kick errors back, but we'll talk about that when we get there. But that's kind of how parametric modeling works, meaning that you can go back, alter things, and it will update and reconfigure based on new inputs. And Fusion 360 allows for both of these. So we're going to mostly focus on parametric modeling. Direct object modeling is more when we get into like surface modeling and such. That'll be later in the semester, because while it's more free form, it has fewer guideline or guide rails. You can very easily just kind of go off the deep end. You'll have to end up like deleting your project and restarting. So that's where it helps. All right. We'll go over this here in a few, not tonight. We'll deal with it later. It's not really important, but there's different file types we'll be saving with this. This when it comes to 3D printing. We'll talk about it later. It's already on, but main different file types are STL, which stands for stereolithography. Basically, that is the baseline format for a 3D model. It does not contain any information as far as like what material it is or like color, texture, anything that you might attribute for modern 3D modeling. This was actually developed in the 80s. We'll talk about history and stuff like that later. I just kind of want to set a baseline for everybody. Newer versions, you have object files, OBJs. These have some approximate surface geometry, so they're better for doing things like more complex shapes and such. STLs kind of flatten things. Have you ever seen how like really basic programs, instead of being able to draw a circle, like a smooth circle, it'll instead have steps between. You should use a different marker. Instead, trying to make a rounded object, it'll have more of like steps. The more steps, the smoother it appears, but it still is made up of these steps. STLs kind of focus on that. Object models are more capable of making smoother and smoother turns. Step files are more common, more widely used. They're more modern one. It's called for STEP, Standard Exchange of Product Data. Way over your head, doesn't matter. The up and coming file format for saving files is called the 3MF, 3D manufacturing format. It's an attempt to make a more universal and modern type of 3D model file saving or file format. Basically, kind of think of it as the difference between like a raw file, like a raw, like literally .raw raw picture file. There's lots of information, but yeah, kind of over compressed, blah blah blah. You can get all kinds of stuff. Actually, no, that would be the other way around, wouldn't it? Think of like a JPEG, which is a really common baseline image. Doesn't have a lot of information, but it's easily compressed, all that such, versus like a raw file .raw. Lots of information, big file, but it's the easiest to input into other things, kind of like 3MF. Not really, but it's kind of. Again, I'm just trying to make some analogies to help you work around what these things are. All right, super friggin' duper, blah blah blah. Where do you start with something? How do you start modeling? It's not necessarily the same way that you would go about, like, say, building something out of wood with saws or, machining equipment, things like that. It is, but it's not, but it's not, but it is. In that sometimes you'll start with a drawing and pull that drawing outward. Sometimes it's easier to start with an object. So like I said, like object manipulation, start with a block and then start cutting pieces away. Sometimes it's best to work with a combination of those things. So like here, this example of how might you make a really basic claw hammer head? Well, in this instance, what they've done is they've made a block, just a square or just a rectangular block. They've made a drawing on that block. So they've taken that block. They made a drawing on that block with that little triangle, extrude cut. So they've cut that chunk away. Now it looks like that inside. Then they've drawn on the side another drawing, an arc, and cut across there. So chopping this whole top section away makes this whole drawing now have a curved top, so on and so forth. Did the same for the bottom. Afterwards, what they've done to make the hammer head, I'll just draw that in. It's a little curvy thing at the bottom now too. The erasing is not happening. To make the hammer head, then they have made a drawing. It would be like out like that. And then that's just half a profile, and used a revolve tool, which means literally taking that drawing, turning it in a circle to create slightly more complex circle with that little stud at the back. That's a really bad drawing. And then use some different tools to say like round out that front corner, called a fillet tool, not a fillet. Fillet is a fish, fillet is an engineering term. It's a curved surface. So there's kind of a weird way of thinking about it, but it's a combination of starting with an object, chopping chunks away, and then adding a drawing and moving that drawing around to create different parts, and then joining them all together to make your finished form. So great, that's one way. Other ways, maybe instead you do an opposite. So like I said, same kind of tools, different order of steps. In this case, to make this little like flange kind of thing, they started with a cylinder, then used the same revolve tool, but instead of creating an object, they used a revolve tool with a profile and chopped that whole complex sketch away from another object. Then they used an extrude tool to cut some complex shapes away, added some holes, call it good. So the same tools used kind of opposite ways to create different objects. Then you have more complex things of like making these tire rims. Wheel rims, sorry. Same thing, revolve, you start with a sketch, turn it around in a circle, you start with a complex, you end up with this kind of complex edge, but it's a cylinder otherwise. Chop out the center, chop out the inside, leaving just the center. Then you would create just one spoke, make it complex, rotate it, make copies in a pattern around. Now you have multiple copies of the same thing. Add some more details like stud holes or lug holes, things like that. So you've got a bunch of different, bunch of different ways you can use the same tools to make completely different things, just depends on the order of steps. And also let the program do the work. Meaning, in this case, they just drew the one, or just made the one set of spokes, finish that out, make it complex, all that, do all the details you need, and then make multiples of the finished thing. Don't try to make each one individually. Don't make more work for yourself. Let the program do the work. So those, and here's just some links for all that stuff. So those are just some basic examples of stuff. Now I do have some, come on. So I do have a bunch of terms here. We can go over those later, but I just want to show you the format for this. CAD, CAM is computer-aided manufacturing. So, you know, CNC machines, technically 3D printers are a form of computer-aided manufacturing. But we'll get into that detail. There's a bunch of different terms that both apply to like terminology, vocabulary, and also tools within Fusion 360 that explain stuff. Just some basics. And if I didn't say so before, if you can, get a mouse for your computer. You can use a touchpad, but it makes it a lot easier. It can be a very, very basic mouse, just a 2-button and a scroll wheel, make your life so much easier. So things like zoom can be controlled with the mouse wheel. Pan is taking your object. Of course, I grabbed the one that's connected with me. Taking your object without rotating it. Pan is just moving it in either direction flat, and then rotate, tumble, orbit. They're all kind of interchangeable. That's literally rotating around. So just the difference between those. On this handout, I've tried to highlight the terms that are also the actual names for a tool in blue. Glossary terms, such as vocabulary, are in black. So I just want to go over a couple of these so it'll help you understand what we're talking about when I move into Fusion 360. So a sketch is your drawings, your flat drawings. So literally like you're sketching something. It's not quite as free form, but your sketch is making lines, making edges. And we're going to talk about the hierarchy here, but those lines can be pulled into space by a tool called extrude. We'll explain what that means. There's going to be a hierarchy of objects in virtual space. Lines can create bodies. I will be making, or at least making myself laugh with really bad jokes throughout the semester of, all right, now we're all going to hide the bodies, or now we're going to split the bodies and chop them up and hide them. No, hiding bot, yeah, it's just toggling the visibility of stuff. But full bodies, so it has 3 dimensions. That's going to be a body in space. The other ones we'll talk about, like chamfer, stuff like that, all that kind of stuff. Component is a full item within the hierarchy. A component can contain bodies, sketches, different kinds of modifiers, like you want to add joints, movement, things like that. So ultimately, we're gonna explain this more, but essentially, component is think of it as the main thing. Within the component, you can have sketches, you can have bodies, that sort. All right, we'll go through the rest of this stuff later and explain some more. At the bottom of this, there is a shortcut list, so just hotkeys on the program. Okay, so that's kind of the basic rundown of what is CAD. All right, so play with it. Those are the basics. Let's move on to Fusion.